Hello folks, well, it's pretty late on into the evening, I think it's 8 o'clock. I thought we'd make a start on this. Hello Richard, no history on this Harry Moss, no meter light, and the original mic, which is still in the box, is dead. Then the note also goes on to say, the enclosed Amstrad 901 is for your parts bin. So there's 3 Harry Moss sets. There's this one, the 325, the 324, which is the TC300 Interceptor, which says Harry Moss, and there's another one as well, which I think is a small one. It's got a bit of a pally. We'll sort that out so that it's legal. That goes in a long way. Is that broken? Yeah, that's broke. Well, that's okay. I'll tell you why. Because on the illegal Maxcom sets like this one, it's the same socket, so we can pinch them off on a scrappy legal set, and that makes it a good thing. I've got one of these at the side of me, which we did not a million miles away, and I didn't realise that it's supposed to have well, that's not the same, is it? No, it's me. That's not a. That's not one, is it? It's a DW900, Kerno DW900. Ah, you see. I think it's the same set and it isn't. Okay, so we don't get PA on this one. So if I remember rightly, they're Uniden type wired. They're made to look like a Uniden set, aren't they? So Harry Moss, there's only one listed, and it says on here it's Cybernet wired. Oh well, I think we'll open it up for a start. Just make some notes. I think it's 325, this one. I'd like to write down the serial number, but it's come off. These didn't come in the first wave of sets. I don't think they were out until either 82 or 83. Can't quite remember what he said about it in his email. So not like anything else I'm aware of. Something just fell out. Tell you what, I'm going to take all the lids off. These that have a packing piece of cardboard inside to stop short circuits, or is that the TC300? Yeah, it has. I do remember daft things, don't I? So it's the PT325 chassis. So hotspots are going to be around the output transistor there. That's okay. And the driver transistor there. So as you can see, this socket's broken. Where did I put his little stub? It's there. So that'll do for now. So obviously we'll sort that out and put a fuse holder on it. So the sensible thing to do is to go and get a Cybernet standard wired knife. So it's lit up. The signal generator on, yes. You can see it's picking up the signal generator. Let's put our extension speaker in. This is the one mounted on the wall. Yeah, it's not wired for that. Here's one that says Uniden on it, so it might be still wired, right? It is. Keying it up, it's doing 3.9 watts. .6 watts on channel 1. On channel 40, 4 watts. Back to channel 20. 1.08 amps. Low power. Could put the picture in picture on and you can see what I'm doing. 20 milliwatts. Back to high power meter, bangs across. I put FSD for full scale deflection. Meter lamp doesn't work, and 100 microvolts on the test set. Just see that we're on frequency, so we'll just do the frequency. 2779112. I'll tell you what, let's pop it on frequency right now. It's hardly out. Assuming it's adjustable. Really good quality trimmer. That'll do me. And let's see where the receiver is. I'll check the signal generator first. It's virtually spot on. Right, let's look at that. So we've got S9 on the signal generator and the meter says 7. So to get 9 on the meter, we need what signal? And the answer is 225 microvolts. Just a little on the ungenerous side. Did I say 225? Switches work. Potentiometers work. Sockets work. It doesn't have PA. Right, so see if we can get down this transmitter. I take it that isn't supposed to have a core in it, but we can check. Of course, I printed off the instruction book and it's got a squirkit diagram. So that means L302 is non-adjustable. It's L307, and L307 is showing as being adjustable, but there's no core in it. So 307, 306 is non-adjustable, it shows. And that is 306, which is non-adjustable. 305 is adjustable. That's 303. That is adjustable. 302 is non-adjustable. 301 is adjustable. So 307 definitely shows as being adjustable, but it ain't got a core. Right. Two expensive dual gate MOSFET transistors in the receiver front end. So I'll tell you what, before we mess about, let's look at the sensitivity. So I'll plug in the test equipment speakers instead of that one on the wall. Right, let's go to the SINAD meter. So at the moment, sensitivity is just about 1 microvolt. I'm between scales. If you want it more accurately, well, it says 0.95 on the other scale, and it says 1.05 on this scale, so we'll put it down as 1. 10 dB. Do I have to touch this set? No. 0.91. And if it does 20, which it does, it's 2 microvolts. Squelch. Full squelch is a lousy 3.9. Wouldn't squelch out to skin off a rice pudding, that. And sensitivity on squelch is not very good at 2.6 microvolts. That's a very poor squelch range. Let's hope something's out and it corrects itself. So the transmitter, we know, obviously that's the power amplifier. before then we've got L601, 602, 603, 604. 604, 603, 503, 504. L60 something, that's going to be transmit. .603, 604. .604 is the first one in the chain. 603, we're not going to touch that. 602 is that? Yeah, it's 602. And that's 601. So they are receiver. Goes to show. So let's see if we can find something out of a scrap set to put in that space there. I wonder if one of these out of an illegal Maxon built set fits. Here's the logic, they're both made in Korea. Just drop it in the works. Well, that's where it should be. It's right in the top, so we are going to have to put, well, it's right in the top there. I wonder if it's got a second sweet spot. Nope. So it's just 4.05 or something like that at the moment. Right, let's look at the other channels. Right, it's 4 watts on 1, it's 4 watts on 20. And it's 4.05 on 40. So I think we can let that go. We're not going to end up with the powers that be coming around. I need to make sure that's got wax on, so because it is very near the top of the travel. That's probably why it's probably what was inside the set, to be honest. So 4.05, 4 watts, 4 watts, and if we can find the meter preset. I'll look at the circuit. It's probably as far as we can go with this today. I may as well try and do deviation because the other test set's been on all day. So if we look where the meter is, does the transmit light work? It does. Right, what's this? Oh, it's there on the circuit. It's so small I couldn't see it. So it's RV2 is TX meter. And that says RV2. Good. And if we can find low power, it's there. It's RV5. That's RV5. Pop the set on low power. Let's give that a quick squirt of the switch cleaner. Waggle it around a bit. Milliwatts. So now we've got the power optimized. It's 1.035. 1.035 amps. It's drawing a little tiny bit less current for a little tiny bit more power. So deviation on this test set, wallow. There isn't very much. So there's either a fault because he thinks the microphone supplied stuff, but then the microphone I've picked at random is exhibiting the same kind of snag. So if we just look at deviation, it's RV5, isn't it? No, that doesn't say 5. We've done 5. It's 3. RV3. It's going to be somewhere down there, isn't it? And that is RV3. We'll just see if it is that one. Wallow. I think there's a problem on deviation. There's nothing getting through. It's very, very low. So that's probably why it's been ditched. So I've had the test set on all day with this planned, and I haven't got the time to fault find. So I'll tell you what, we've just got a few minutes. We'll just do the receive, and then it's things like fixing that and finding why there's no deviation. Right, detector, so I want camera 3. 100 microvolts on the test set, enough volume for a sensible trace. The detector coil, I'm pretty sure is going to be that one. For something 05. Don't think there's much change there. So we haven't touched these two which have got the wax in, which are the first transmitter stages. Don't think I've missed them. There's no point in adjusting them because they're clearly right that the thing's doing 4 watts and it's balanced. That's going to be the VCO, so we're not going to touch that. So we've got a 10.24 into the receive chip, so we will adjust that. It's L506, so that's going to be in a weird position, I expect. I bet it's that one. It is. There's the only bit with no wax on it. Well, I'll tell you what, we'll do that now. Sometimes you can see them on the S meter, sometimes you can't. Let's put decent signal on like that. See if you can see it on the SINAD meter. Do you know what? I've probably only seen 2 or 3 of these in my life. Let's put a bigger signal on so I can see the meter. And this is one which you can see on the meter. So, getting the same as we're getting on the SINAD meter, it's still the same peak. So the front end were those two. 501, 502's front end. Of course, having accidentally adjusted them thinking they were the transmitter, I've put them back to some extent where they were. Here's the IF. That's the most out of the whole set. So now for 12 dB we've got a new figure. 0.27. That's better than 1, isn't it? You can tell it's not a Uniden because it's more sensitive. 0.23. And 20, 0.53. So hopefully we can set the squelch. What a clunky squelch. Squelch is going to be somewhere around here. So there's our squelch control. So the wiper of the squelch control goes via this network to the MC3357. One side of it goes to the detector coil. The other side of it, there's a preset, it's there, it's RV1. Thank goodness for that. RV1. I'm expecting it round here because that's the receive circuitry. Hello, where are you? There's a filthy looking object here. It's filthy because it's silver plated. That's it anyway. So that's, see whether we've got it where we want. It's good over to the attenuator. So we're at 10 microvolts. I've got the squelch to full on the radio. I want it to open at 100. So there it is. Yep, that's where I want it. But is the sensitivity any good? But then you see the receiver was so far out on the IF. We're in with a chance. I've set the squelch on the radio. Put the signal generator back on. 0.7. So 0.7 on the sensitivity, 100 microvolts. We've got an absolutely superb squelch range. So that's pleasing to call it a day on this radio. So there's something wrong with the transmitted audio. It could be DUF capacitor. Obviously I'm going to have to check it with a third mic, like a new one, like our standard one. I'll just take the boxes off where I've got the mic stashed, because I've just pulled this off the bench. I expect it's working. It's on the bench of working things, but when you're not quite sure, it's best to check. So audio goes in, it's Uniden. So this is wrong. Uniden is wiring number 2, so audio is on pin 2. That's receive. That's ground. Now this is the audio. This is the audio, folks. That's pin 2. That's transmit switching. So it goes through a choke. It goes into this chip. Let's just do RV2 while we're at it. Can we find another preset? Yes, that one. Just do the meter. That's now S9 for 100 microvolts. So that's done that. There's our deviation. So you've got an electrolytic capacitor there which could have failed. Got an electrolytic capacitor there which could have failed. And we've got an electrolytic capacitor there which could have failed. We've also got an electrolytic capacitor there which could be taking it down to deck. And we've got an electrolytic capacitor there which could also be taking it down to deck. So I think we'll just do them all. There's 5 of them. And then we'll start worrying about fault finding from then on. So I'll see you tomorrow. So next day, for the reference, I've dug out the standard replacement mic wired Uniden. So knowing that the customer says his original mic doesn't work, our Uniden mic doesn't work, so does our normal test Uniden mic work? Put the power back on. Wallow, wallow, and we've got perfect audio. Well, there you go. Testing 1 2, testing 1 2. So there you go. Sometimes you've got a number of DUF mics, haven't you? Right, well, the next thing we'll explore is the meter lamp. So on these, we take the front off, which comes off in 2 sections. How strange. And I've unscrewed the TX LED so we can withdraw the meter enough to look at the bulb, or lamp in correct terminology. Just on a little tag strip, is it? I think more that's happened here is that the wire snapped because of corrosion rather than the bulb fail. So we've got the wire ended bulbs, the RS360-7913. Especially if I can get one out of the packet. A little tiny bit smaller. Made in Korea, so it's in line with the manufacturer of the radio, made in Korea. So it goes like that. Right, we'll power it back up. Probably a bit bright. We'll see when the meter's put back together. It receives full rail voltage, so these are always 12-volt bulbs, so you do need to drop a bit off. I'll put the meter back together and we'll put a resistor in somewhere else. That's probably why it failed, because it's not a big hour set. And then they put a piece of tape over, so I'll have to go and get a piece of tape off Mr. Chippy's bench. Right folks, so I've done the socket, so having recovered it off that scrappy legal radio. It's exactly the same product from a song. So we're now, whoops, wrong switch. That's how it should be, but I don't want it to be that bright. I'm not a believer in modifications, but just sometimes some things like that are silly. This is the data sheet for the lamp I've fitted. So the RS367913 is 5,000 hour life. Usually the 1,000 hour. These are 60 milliamps. Why didn't it say that on here? Anyway, they are 60 milliamps. So we need to have a calculator. Where's the pink calculator? The pink calculator isn't on here, Mr. Tango. We need to lose some volts. It's a 12-volt lamp, and I want to present it with 11. Right, so what do we want to do? Lose 3 volts. So $50 ohms. So we want to lose 3 volts, divide that by 0.06, and we ended up with 50 ohms. So that's V divided by I gives us R. So do this another way. 13.8. No, we want 11. 11 minus 13.8. So it's 2.8 volts we're wanting to lose, if you see what I'm doing there. So we'll call it 3 volts. We'll start again. So then we've got 3 volts. It's 0.6 of an amp. It's 60 milliamps, 0.06. So divide by 0.06 and we get 50 ohms. So that's what we're doing. So we'll find a preferred value somewhere near there and we'll stick it somewhere appropriate. Right, so we can see that one end of the lamp is just tied to the earth ring of the mic socket here. So can we unsolder that without ruining everything else? There we go. So what we're going to do is to put our 50 ohm resistor. It's 51 ohms, which is the nearest preferred value. I'm going to go up rather than down. So we'll just chop one end. And of course it's very visible, so it's easily reversible if somebody wants the lamp to burn out every 10 minutes. So that's our resistor. Probably just chop that off, it's a bit gnarled. Just chop the end off. I'll put some sleeving on. So I've only probably seen another 3 of these. And I'm so chuffed that we got the receiver so much better and the squelch so much better. I think we've covered it on this channel before. I'm not looking forward to having the adverts forced on this channel by YouTube. At the moment you're going to get 2 adverts at the beginning, 2 adverts at the end, nothing in the middle, and you're going to get adverts like everybody else's all over the place. It's nothing I can do, and they're bound to be inappropriate, aren't they? What was I watching? Something on funeral directors, and the next thing they're trying to sell me a smoking barbecue. There we go. So that's done that. There's the nasty bit of tape which was around the meter. So it's not going to be visibly dimmer, but we're now going to be presented with 10 volts, 11 volts, 10.5, something like that, instead of 13.8. I suppose I could have put the meter on that, couldn't I? So there's our, are we on the, can't tell, no we're not. So there's our, it is, it's there. There's our full rail voltage, 13.78. And there's our new improved voltage of 10.7. So now our 12 volt lamp, which lasts 5,000 hours at 12 volts, will last more than 5,000 hours and not be like a headlight. We'll need to do his power lead. We need to look at his mic. We don't mend mics, but he's asked me to, so obviously there's a fee for that. Here's how to work it. So what we're supposed to, well, how's it supposed to work? 0.7 for 20 dB. What did we end up with for 20? We ended up with 0.53 for 20. Usually when they quote 20 dB it's a bit fanciful. And we have our test set to EMF rather than PD, so it's harder to achieve. Most of these are going to be in PD mode. Good, so that's that done. I just need to put some wax or something on that. I don't have any wax on here. What can we drip wax out of, folks? Is there an illegal CB full of wax? It's not candle wax, but I'm going to have to use candle wax. What else do we need to do? We just need to check deviation. The machine behind me should have warmed up. And I think Bob's our uncle. The thing to do at this point would be to just do the deviation with our known working mic, even if I can't get the locking ring on. Picture in picture on. We want camera 1. Wallow. What channel are we on? Testing 1 2, testing 1 2. Wallow. 1 2 1 2 1 2 wallow 1 2 wallow wallow. So you can see it's doing like 3.5. Now of course that's at full chat because there was no transmitted audio. So we'll go to the deviation meter behind me, which doesn't play shenanigans. It's about 3.2, so I think the Marconi is right today. So we came to the conclusion, didn't we? the deviation controls, no doubt that one down there, but I've forgotten because it was yesterday. That's it. So that's our 2.5 absolute peak. Back to this test set. Wallow 1 2 1 2. It's showing about the same, so that's good. So if we go back to his, oh, and of course this our walkie-talkie on. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. So we know there's audio there. So what we got here? Harry Moss original mic. Wallow 1 2 1 2. Testing 1 2, testing 1 2 3 4 5 1 2. Yeah, right. We better open it up. Could be the switch rather than the mic element. Because the trouble is, if we swap the mic element, it's not going to sound like it should do, is it? Going to measure for it being open circuit or not. Yeah, it is, isn't it? And what's going to happen, you get the corrosion from people's breath, and it's this glue, isn't it, which goes hygroscopic and then breaks the insides. Really frustrating. And it's not like I have a stash of mics. No, it's open circuit. Well, he's right there. So of course all we can do is to put something in that works. Right, we've got some new elements in stock. Can't remember whether we got these from Maplins before Maplins went. Or whether they come from one of our wholesalers. I'll look it up anyway. hopefully, I mean, it's the same kind of diameter-ish. A bit sloppy. Can we put that on? And is there enough room for the lid to go on? It's going to want some foam in there, but at least it's gone into that adapter which was on the original, so I'll send him that back to posterity. But right, let's get that wired up, at least it'll work. I'll tell you what, we've only got about 3 of these in stock. We've got red paint there, so I'm assuming that's the positive, just for people who are worried about which way the diaphragm's going. Not like we're doing stereo, is it? But we'll do how we think it's supposed to be. Right, so while it's in bits, testing 1 2 1 2 1 2. Well, we've got no audio, but let's test how many. So you can have multiple faults. You know, when you're doing electronics as at college, you know, they'll put faults on things for you to fault find, but they only put 1 fault on. They don't put 3 faults on and 5 faults on. But the reality is that that's how things are. Well, you know what? This new one's open circuit. I'll just check it's not the soldering on the top. This is the trouble, you know. How long have we had that in stock? 10 years? See if we've got another one. Right, so with the new one working and the old new one not working, I've been across to the organ workshop and we've got wad punchers. So I've got a piece of sponge and I've cut it with the wad punch, so it's a professional looking thing, and it just neatly goes in the hole like it's a factory item, even though we all know it isn't. And hopefully it won't rattle around. So when we do the on-the-air test, we must use the standard replacement mic, but we'll test this. But of course it isn't going to sound right, the original element, is it? But of course it's nice to have the original mic, even if it's got new innards. I'm not going to be stupid tightening those, because we all know the element, the mouldings can snap. Testing 1 2, testing 1 2 1 2 1 2, testing 1 2, wallow. Right. not lacking gain, is it? So I'm just going to compare deviation now. I'll try and stay on the Marconi test set. Testing 1 2 1 2 1 2 1 2 wallow wallow 1 2 wallow. This one. Testing 1 2 testing 1 2 1 2 wallow 1 2 1 2 1 2 wallow. They're the same on deviation anyway. Right, that's that. So that's his mic fixed. So new connector, a new 40-year-old connector, a meter lamp, tuned the radio. It wasn't far out on transmitter, it was a bit lopsided. We don't know where it was on deviation before because I had to turn it up to full 2.2 to 2.5 kilohertz. So it's 51R resistor, mic element, STK01780121177. Second hand good. We'll have a fuse holder to put on that and to remake that power lead, but I don't need to show you how to solder a fuse holder onto there. These are rewirable, these particular power plugs, so you can go to all the trouble of putting a complete new cable in, but seeing as the fuse holder's got to go in there, it means we'll splice the black, but it will be well done and with heat shrink tubing and that. Okay, well, I think it's time to put this back together. It certainly had some corrosion, hasn't it? Let's turn it off. I've gone in depth with that meter lamp because it's absolutely bonkers having a 12 volt bulb in a 12 volt in a 13.8 volt product. Doesn't need me to explain that, does it? It's not going to last long, and we know this set's not massive hours. I mean, I think the original lamp's going to be 1000 hour at the rated voltage. You put 13.8 volts instead of them being 1000 hour, they might be 100 hour. Makes a massive difference. Anyone with projector lamps will know about running them at lower voltages and putting up with a dimmer picture. Oh, don't you have 35mm slideshows every night? Oh, it's just me, is it? Isn't it wonderful not having a television? Better put the soldering iron back on. That's a hefty speaker, really. It looks original. It's the only thing we haven't actually tested. Turn the little walkie-talkie off. So did I tell you about Retivis contacting me and saying did I want to do some partnership with them? They would send me some freebie radios and I could review them. So I wrote back and I said, well, yes, anything that's suitable for the UK legal CB market, but do make sure you've looked at some of the new reviews, because if your radio doesn't do what it says on the tin, I will say so in the review. You know what, they haven't got back to me. That was a week ago. So do you think I ought to spend my own money and buy some Retivis CB radios to see why they don't want to do a partnership with me. They're probably fantastic, but there's a possibility they don't do what they say on the tin, isn't there? That was always the problem with magazines, wasn't it? And getting samples sent in, either loan or to keep, and then how do you say the radio's crap? And you know what, some of the really crap radios, there's still uses. You know, you have a particular job in mind, and what might be a crap radio to somebody is exactly what you want. Right, there we go. Did we test the speaker? No, we didn't. It's better switch on then and see if it works. To do that, you have to plug a mic in. So we'll use our standard replacement mic rather than the one we've just made up. Yep. We'll come off the test gear and onto the aerial, which, as I say every time, is an Antron 99 or a something 99, 18-foot end-fed fiberglass mounted just above gutter height on a single-story building, broadside into an apex concrete tiled roof. Well, I think that's splendid. One and a Roger.
I've never come across it before.
And there we have it, a Harry Moss 325 from about 1983. Thanks for watching.